Welcome to the LangChain for LLM App Development short course by Simplilearn. So we will initially start with what is LLM App Development. So LLM App Development is a process of building applications that utilize large language models like GPT-3 or GPT-4 to understand, generate and process human language. So these applications can perform tasks that require language comprehension such as question answering, summarizing text, creating content, or even having conversations. So imagine you have a smart assistant on your phone. You ask it, "What's the weather like in New York tomorrow?" And within seconds, it gives you a clear, human-like response. That's the powered by LLM App Development. But it's not just limited to the weather updates. LLM apps can do much more. So let's dive deeper with examples. So first we have customer support chatbots. Imagine you are visiting an e-commerce site and have a question about your order. So instead of waiting for an agent, you instantly get a response from an automated chatbot. It's able to answer questions, solve problems, and even guide you through the buying process. That's an example of LLM app in action. Then we have writing assistants. Think about tools like Grammarly or GPT-powered writing assistants. You are writing an email or a report, and the app suggests improvements or even completes sentences for you. It's like having a virtual editor by your side. Then we have code generation tools. So imagine you are coding and you don't know how to create a specific function. You type your request like create a Python function that adds the two numbers, and instantly the tool generates the code for you. LLMs can help developers code more efficiently by suggesting or writing based on the natural language instructions. Then we have document analysis. Imagine you need to read a long legal contract, but you don't have time to go through every clause. You can upload it to an LLM-powered tool and it will summarize the key points for you. It reads and understands documents like a human would. So now let's move on and understand what is LangChain. So LangChain is a powerful framework that helps developers build applications using large language models like GPT-4. It allows you to easily connect LLMs to the real-world data, tools, external systems to create more advanced, interactive, and intelligent applications. Think of LangChain as a toolkit that helps you build the smarter apps powered by LLMs. Makes easy to work with the language models. It retrieves data from the documents or databases. It automates task and decision making. It keeps track of the context or memory in a conversation. Now, moving on, we will understand the core components of LangChain. So LangChain is designed with several core components that make it flexible and powerful for building the LLM-powered applications. So here's a simple breakdown of the core components. First, we have models that generate text or handle language tasks. Then we have prompts that define how to ask the model questions or request actions. Then we have chains that combine the multiple tasks in sequence or the workflows. Then we have memory that keeps a track of the past interactions for context. And finally, we have agents that make decisions on what actions to take dynamically. Then we have tools, that is the external systems, that is the APIs, databases, etc. that can be accessed by the agents. Then we have retrievers, that is a search and the pull relevant information from the large datasets. And then finally we have output parsers, structure the model's free form output into useful data. These components work together to create intelligent, flexible and modular LLM-based applications that go beyond the simple text generation. So, we'll understand how LangChain in LLM app development actually helps. So LangChain is like a toolkit that makes it easier to build smart applications powered by the large language models like GPT-4. So here's how LangChain helps you develop the powerful LLM apps. First is easier integration of LLMs. So LangChain makes it super easy to plug in models like GPT-4 or GPT 3.5 or others. You don't need to worry about the complicated setup processes or coding everything from scratch. Then, for example, imagine you want your app to use GPT-4 to generate text or answer questions. So with LangChain, you can set this up with just a few lines of code. Moving on, Number 2, we have automate some multiple steps like the chains. So in traditional app development, you would have to manually combine different steps like asking a question, processing the answer, and handling data. So LangChain simplifies this by allowing you to chain actions together, automating multiple processes. For example, if you want to build a chatbot, LangChain helps you chain steps such as getting user input, then sending it to the LLM for processing, and then finally returning the response to the user. So this makes development faster and less error prone. Now moving on to the third one, we have easy data retrieval. So imagine your LLM needs to pull information from a huge pile of documents or data. So LangChain makes this easy with retrievers. You can set up systems to search through documents or databases and bring back the most relevant information. For example, if your app needs to answer questions about the company's quarterly report, LangChain can help you automatically pull the most relevant sections from the report using a retriever. Then we have memory for smarter conversations. So when building apps like the chatbots or virtual assistants, it's important to remember previous interactions. LangChain gives you the ability to add memory to your app. So this means your LLM can remember what was said earlier and respond in a more context-aware way. For example, if you're chatting with a virtual assistant and ask, "What did we talk about yesterday?" the assistant can refer back to your earlier conversation, and thanks to LangChain's memory. Now moving on, we have decision making with agents. LangChain also provides agents that can make decisions based on the information they receive. So these agents can decide what actions to take, such as querying a database, calling an API, or another question all on their own. For example, if a user asks, "What's the weather in Paris?" an agent could decide to fetch the weather from a live API, ensuring the answer is accurate and real-time. Then we have tool integration for added functionality. So LLM apps often need to interact with the external tools like the APIs, databases, or websites. So the LangChain makes it easy to connect these tools to your app, enabling the LLM to take actions based on the real-world data. For example, if you want to build an app that helps users book flights, LangChain can help you integrate the flight booking APIs so the LLM can make the real-time bookings for users. Then we have point number 7 as simplifies the complex tasks. So LangChain takes care of the complicated parts of the app development for you. So you can focus on building the core functionality of your app. So whether it's chaining steps, integrating external tools, or managing memory, LangChain simplifies everything and helps you develop more advanced LLM apps with less effort. So it's a game changer for the developers who want to create intelligent, real-world applications using LLMs without having to build everything from the ground up. Now, let us understand why is LangChain preferred. So LangChain has become the go-to framework for developers working with LLMs because it offers a lot of advantages that make app development faster, easier, and more powerful. Here's why it's preferred. The first one is modularity and flexibility. So LangChain is designed to be modular, meaning you can pick and choose the parts you need for your app. You don't have to use everything, just the components that suit your specific needs. So whether you need a model, a memory system, or an agent, LangChain lets you mix and match components seamlessly. Why it is good? You can actually build only what you need and make your app more customizable. Then let's move on to the next point. We have faster development and prototyping. So with LangChain, you can get from idea to working app quickly. It comes with the pre-built components that you can use right away, like chains, prompts, agents, and memory. So this makes it easy to prototype and test your ideas without reinventing the wheel. So why it's good? It saves your time and allows you to develop the features faster. Then we have built-in tools for the external integrations. So the LangChain makes it easy to connect your LLMs to external tools like APIs, databases, and external data sources. So whether you need to query a database, use a web search API, or interact with the custom tools, LangChain has you covered. So now moving on, we have memory handling for the context-aware apps. Most LLMs don't have memory, meaning they forget everything once the conversation ends. So LangChain lets you store and manage memory, which is essential for the building apps like the chatbots or virtual assistants that need to remember the past interactions. Then we have decision-making agents. So LangChain's agents are a powerful feature. So these agents can decide what actions to take based on the input they receive. So whether it's querying a database, calling an API, or asking for more information. So this makes your app smarter and more autonomous. Then we have, it simplifies the complex workflows. So with LangChain's chain, you can automate multiple step processes that combine prompts, models, and tools. This is especially helpful when you need your app to follow a sequence of actions. It's good because it allows you to build the complex workflows easily without having to manually stitch everything together. Then we have active community and open source. So LangChain is open source and has an active community of developers constantly improving it. So this means you have access to the new features, updates, and support from the other developers as well. So in short, LangChain makes LLM app development simpler, faster, and more powerful. It gives you the tools you need to build advanced, smart apps without having to code everything from the scratch. So now let's move on to the next chapter and see the core components in action. So there are various components that work together. So the first one is models. So let us see what are models. In the world of LLM app development, a model is essentially a smart program that has been trained to understand and generate the human language. So these models are built using huge amounts of data like books, websites, articles, etc. to learn how language works, including grammar, facts, reasoning, and context. In simple terms, a model is like a brain that can read and write language. You can ask it questions, give it prompts, or provide it with information, and it will respond in a way that makes sense based on what it has learned. For example, let's consider an example with GPT-3 or GPT-4, two popular language models developed by the OpenAI. You ask, what's the capital of France? The model processes it. It understands that the question is about geography and recognizes the capital and France in the context of the countries. Then it responds to the question as the capital of France is Paris. In this example, the model, like GPT-4, has learned from all the text it has trained on that Paris is the capital of France. The model uses its language understanding to generate a human-like response. Now moving on, we'll understand what are prompts. So in the world of large language models like GPT-4 or GPT-3, a prompt is simply the input or instruction you give to the model. It's like a question or a request that helps guide the model in generating a response. Think of a prompt as a way of asking the model to do something. So whether it's answering a question, completing a sentence, or even writing a story. Then we have a very few examples of prompts and what the model would respond with. So the first example is simple question prompt. That is, what is the capital of Japan? The model's response would be, the capital of Japan is Tokyo. Then we have an example for the creative prompt. The prompt is, write a short story about a cat who loves to swim. The model's response would be a creative story about a cat learning to swim and having fun. Then let us understand what are output parsers. An output parser is a tool that helps to process and structure the text generated by a language model. When a language model generates, it might be in the form of a long paragraph, sentence, or even free from text. But often we need to extract the specific pieces of information from that text, clean it up, and format it into something useful. Then we will see all this in action. So regarding the OpenAI API pricing, you can go directly to this openai.com API pricing wala website, and then when you scroll down, you will see and explore the detailed pricing, and you go there and you will basically find all the latest models with the input, the cached input, and the output as well. So in this course, we are using the GPT 3.5 Turbo, and its input is $3 and the training is $8. And if you contact the pricing, you will see it cost $0.5 and the output is $1.50. You can basically take up any API that suits well in your project. So, what's happening in this code is pretty straightforward. So first, the OS and the OpenAI libraries are imported over here. OS helps us work with the operating system, and here it's used to grab the environment variables like the API keys, while OpenAI is the library that lets us interact with the OpenAI's model. So next, the .env library over here is brought in. This is super helpful because it allows us to store the sensitive information like the API keys in a .env file. So instead of hard coding them into the code, which would be very risky. So the find .env function looks for the .env file, and the load.env loads its contents into the environment. This is crucial because it makes the API key from your .env file available to the Python code as an environment variable. So finally, the OpenAI API key is pulled from the environment using the os.environ OpenAI API key, and it's assigned to the OpenAI API key attribute. So any calls to the OpenAI's API are authenticated using that key. So this way you can actually use the OpenAI's services like generating text without exposing your sensitive keys directly in your code. So let's run this. So in the next code over here, the code is handling the deprecation of an LLM, that is a large language model, by checking the current date and the setting the model version accordingly. So it first grabs the current date using the datetime.datetime.now.date and stores it in the current date variable. Then it defines a target date of the June 12, 2024 as a point after which the model should switch to a new version. So in this case, GPT 3.5 Turbo. The code checks if today's date is after the target date. So if it sets the model to GPT 3.5 Turbo. So if the date is still before June 12, 2024, it continues to use GPT 3.5 Turbo 0301, which is an earlier version. So this allows the code to basically automatically adapt to the deprecation of the older models. So by switching to a newer one when the target date arrives. Then let's run this and move on to the next code. So this function, that is getCompletion, takes a prompt and a model with a default value set to the LLM model variable to generate a response from the OpenAI API. It starts by formatting the input prompt into a message that's structured in a way that OpenAI API understands, with the user's message as the content. So then it sends this message to the OpenAI chatCompletion API using the OpenAI.chatCompletion.create method, specifying the model, the message, and a temperature setting of 0, which means the model will give more deterministic, less random responses. So basically, it returns the model's response by accessing the first choice in the response and extracting the generated text content. This function especially sends a user's prompt to the model and then returns the answers it generates. So we will run this. Now here, when you call that getCompletion, what is 1 plus 1? The function sends the prompt, what is 1 plus 1, to the OpenAI model. So this model then processes this prompt and generates a response. Since the default model is set to LLM model, it uses that model to compute the answer. The function then returns the model's response, for example 2, which is extracted from the API response. The function essentially asks the model to calculate 1 plus 1 and then return the result. Let's run this and you can see 1 plus 1 equals to 2. Let's now move on to the next one. Now here, the variable customer email is assigned a multi-line string using the triple quotes. So which contains a playful pirate themed message from a customer. The message describes the frustration of the customer whose blender lid flew off, creating a mess, and they are upset that the warranty doesn't cover the cleaning cost. So the backslashes are used to break the string into multiple lines for readability, but the string will still be treated as a single continuous piece of text. So essentially this is just storing a customer's complaint in a variable with some fun pirate language. So let's give this as input. So here the variable style is being assigned to a multi-line string that describes a style guide for writing. So the string specifies that the writing should be used American English and be in a calm and respectful tone. So the backslash is used to break the string into multiple lines for better readability, but it still remains one continuous string. So this string might be used later to guide the tone and the style of the responses or messages in a program. So here in this code, the variable prompt is being created using a f string, that is a formatted string. So which basically allows you to embed variables directly into a string. The prompt instructs the model to translate the text enclosed by a triple backticks into a specific writing style defined by the variable style. So the customer email which contains the customer's message is placed between the triple backticks, which is often used to denote the code or the pre-formatted text. The f string makes it easy to insert the value of the style and the customer email dynamically into the prompt. So finally, the print prompt will output the full prompt, showing the instruction to translate the customer's complaint into the desired style. So we'll run this. And now let's see the response. Response is equal to, we'll call the get function get completion, and inside it would be prompt. So let's run this. So in this line, the function get completion prompt is called with the prompt created earlier as its input. So this prompt, which asks the model to translate the customer's email into a specific style, is sent to the OpenAI model. The model processes the prompt and generates a response based on the given instructions. So the result of the API call is stored in the variable response, which will contain the model's translated version of the customer's email in the requested style. So let's move on to the next one. So here basically the variable response stores the output from calling the get completion prompt function, which sends the prompt to the OpenAI model. The model then processes the prompt and returns a response such as the translated email in the specified style. So you can see I'm really frustrated that my blender lid flew off and splattered my kitchen walls. So basically it is the complaint. So here we will just see how to do this with LangChain. So here we are passing pip install upgrade LangChain, and let's see what happens. So this line of code is importing the chat OpenAI class from the langchain.chat models module. So the chat OpenAI is a class provided by the LangChain that allows you to basically interact with the OpenAI's models in a chat-based format, making it easier to integrate the conversational AI into your application. So by importing it, you are preparing to use this class to create the chat-based interactions with OpenAI's language models in your program. So let's run this. So in this code, a new instance of the chat OpenAI is being created with the temperature set to 0.0 and the model set to the variable of LLM model. So the temperature parameter controls the level of randomness and creativity in the model's response. So by setting it to 0.0, you are telling the model to generate very predictable and deterministic answers with little to no randomness. So this makes the model's responses more focused and consistent. So the model is set to use whatever model is specific in the LLM model variable, which could be something like GPT 3.5 Turbo or another version. Now you basically can see the output. So in this code, the variable template string is assigned a multi-line formatted string. So this string is structured to ask the model to translate the text enclosed by the triple backticks into a specific style, which will be dynamically inserted using the style. The text placeholder is also used to represent the actual content that needs to be translated, and both style and text will be filled in the values passed to the template. So the backslashes are used to break the string across multiple lines of readability, but it remains one continuous string when executed. So this template will be useful when you need to generate a prompt with specific content and style dynamically. So in this code, the chat prompt template class is imported from the LangChain prompts to create a prompt template for chat-based interactions. So the from template string method is used to create a prompt template using the previously defined template string. So this method takes the string with the placeholders and turns it into a reusable template that can be dynamically filled with the specific values from generating prompts for the model. So this allows for consistent and flexible prompt generation where you can easily customize the text and style for each use case. So in this code, the prompt template messages 0 prompt is accessing the first message in the prompt template object and retrieving its prompt. So by referencing to 0, it's selecting the first message from the list of messages in the template. Finally, dot prompt extracts the actual prompt from the first message, allowing you to see or modify the template before it gets used to generate a dynamic prompt for the model. So let's run this and you can see the first prompt. So in this code, the prompt template dot messages dot prompt dot input variables is accessing the input variables from the first message of the prompt template. So the prompt template was created using the chat prompt template, and each message in the template was a prompt with the placeholders like the style and the text. So by referencing to the input variables, the code is retrieving the list of the variable names that are used in the prompt template. So this helps you to understand which values need to be provided to complete the prompt before it's sent to the model. So in this code, the variable customer style is assigned to the multi-line string that describes a specific writing style, the American English, in a calm and respectful tone. So the backslash at the end of each line allows the string to be split across the multiple lines for readability. So it will be used when interacting with the customer, possibly for generating responses in a polite and professional manner. So let's give this as input. So in this code, the variable customer email is assigned a multi-line string containing a playful pirate themed message from a customer. So here again the backslash at the end of each line provides you to split the string across for readability, but it remains one continuous string when stored in the variable. So this message is designed to simulate a humorous complaint, like for testing or demonstration purposes, with a fun pirate content. So let's run this. So here the prompt template dot format messages method is being used to fill the placeholders in the prompt template with specific values. So the style equal to customer style and text customer email are passed as arguments, which means the placeholders, that is the style and the text in the prompt template, will be replaced with the contents of the customer style, that is the writing style, and the customer email, that is the customer's complaint. So the result stored in the customer's messages is a formatted message where the dynamic values are inserted into the template, creating a customized prompt that can be sent to the language model. So this basically allows you to generate the context specific messages based on the input variables. So let's print this. And basically you can see, you can print the type of customer messages. You can see it is a list, and customer messages 0, that is the first message. It is langchain.schema human message. Now let's see the first customer message we have. So now basically you can see, now here it is basically the call to the large language model to translate the style of the customer message. So let's run this. And now let's see the response that is changed. Oh man, I'm really frustrated that my blender lid flew off and made a mess of kitchen. And now basically you can see the difference. So here basically the variable service reply is assigned to a multi-line string that represents a service response to a customer's complaint. So the message is written in a direct and somewhat casual tone as well, explaining the warranty does not cover the cleaning expenses. So this reply provides a straightforward explanation, although it's a bit blunt, but yeah, part of mock or example response. This is as well an example. So the variable service style pirate is assigned a multi-line string that describes a specific tone for the communication. So again, it sets the stage for generating the responses that are both courteous and the pirate-like manner. So let's run this. So in this code, the prompt template dot format messages method is used to gain a format new message, but it's time for the service reply. The style is equal to service style pirate and the text equal to service style reply and passed as arguments so that the placeholders style and text in the prompt template are replaced with the pirate themed service style and the actual service reply. The result is then stored in the service messages. This will be a formatted message as well. So finally, print service messages 0.content prints the content of the first formatted message, which will display the service reply. So let's see this. So finally, in this code, service response equal to chat service messages sends the formatted service message to the chat function, which interacts with the OpenAI model. The model then processes the message and generates a response based on that particular prompt. The resulting response is stored in service response. Finally, we are printing it is used to basically output the content of the model's response in the service response.content, which will be translated service reply generated in the specific pirate tone and displayed for you to see. So now here we will begin with the output parsers and we'll see how it plays. So this code is a JSON object, that is JSON means JavaScript object notation, that contains some data represented in the key value pairs. Here's what each part means. Gift : false indicates that the item is not a gift, and false is basically a boolean value. So delivery day is equal to 5, which means the delivery time for the item is 5. Price value is equal to pretty affordable, provides a description of the price saying it's pretty affordable. Now let's run this. So basically it is a customer review and a review template, the two variables over here, and this is a multi-line string that contains a detailed review of the leaf blower, and the review is inserted into the template using text, and the model is expected to output this information in the JSON format with the specified keys as gift, delivery days and price value. So this setup is structured to automatically extract and format the relevant details from the customer's review. So let's run this. So in this code, the chat prompt template dot from template review template is used to create a prompt template from the review template string. The review template defines a structured prompt that guides the model on how to extract the specific information from a customer review. So by calling the from template, LangChain is converting the review template string into a chat prompt template object, which can now be used to generate the dynamic prompts. So finally, we are printing the prompt template, allowing you to basically see the structure that will be used to extract and format the data from the review. So in this code, the prompt template dot format messages basically formats the review template with the actual customer review text. So this set fills in the placeholder in the template with the content of the review. So next, the chat OpenAPI object is created with the model set to LLM model and the temperature is set to 0, which ensures the model's responses are more deterministic and less random. So the model generates a response and then we are printing it basically, which will be extracted information from the review. That will be a JSON format. Basically, this allows the program to automatically analyze and extract the details like whether the item was a gift, delivery time, and the price value. So now basically we are seeing the type of response.content, and you can basically see it is a string. And now let's see this. And now you can see it has shown an error. And why so? It is showing that str object has no attribute get. Now let's solve this. So now here in this code, the two classes are being imported from the LangChain's output parsers, the response schema and the structured output parser. So together these classes help manage and structure the information the model generates, making it easier to extract and use in your application. So here in this code, there are 3 response schema objects are created to define the expected structure for the model's output. So each schema represents a specific piece of information that the model should extract from the customer review. So we have gift schema, delivery day schema and price value schema. So these schemas are then grouped into a list called response schemas, which will be used to guide the output parsing, ensuring that the model's response is structured and matches the expected format for each piece of information. So here the line structured output parser, this creates a new structured output parser using the response schemas defined earlier. So this parser is responsible for interpreting the model's response and ensuring it matches the structure specified in the schemas. So by passing the response schemas list, you are telling the parser what kind of data it should expect and how to organize it. So this allows the model structured text output to be automatically parsed and formatted into a structured format, just like the Python dictionary or JSON, based on the schemas provided. So here in this line, the output parser.get format instructions is being used to retrieve the format instructions from the structured output parser. So these are essential guidelines for a template that tells the model how the output should be structured to match the defined response schemas. So by calling this method, you are getting the necessary instructions that will help the model generate a response that fits the expected format, making it easier for the output parser to properly interpret and organize the data later on. So in this line, we are basically printing the format instructions, and let's print this. And you can see this is a JSON file. And now here basically you can give one review template to some sort of strings, and then you can basically chat prompt template dot from template, and you can even prompt dot format messages over here, and then you can run this. And here basically you are printing the first message in the content, and you can see you have got this. So here basically you can get the response equal to chat messages sends the formatted messages to the chat function, which interacts with the OpenAI model, as I have explained earlier. So this response will be then used for further processing or display. And now here we are printing the response content, and you can see gift true, delivery days 2, price value. It's slightly more expensive than the other leaf blowers out there, but I think it's worth it for the extra features. So in the next chapter, you will see how to basically feed the memories to the model. So sometimes it's very necessary for a chatbot to remember your conversations. The previous conversations are helpful to be remembered by a customer support chat. So in this chapter, we will basically see how we can actually import memory to the models. So in this code, we are setting up the environment for our project. It starts by importing the OS module, as we have done previously, which helps interact with the operating system, and then brings in the load.env and find.env from the .env package. So these are helping to load the environment variables from .env file. Then we are having to store the sensitive information like the API keys. Then find.env function looks for the .env file, and the load.env loads its contents into the environment, so you can access these variables in your program. So let's run this. So this code is designed to handle the deprecation of a particular version of the large language model. It first imports the datetime module, which allows you to work with the dates and the times in Python. Then it gets the current date using datetime.now.date. Which then fetches the current date. Then it defines the target date, which is in the case of June 12, 2024. The code then checks if the current date is later than the target date. So if it is, it sets the model to GPT 3.5 Turbo, assuming that after this date, the older model version is deprecated. So if the current date is still before the target date, it uses the GPT 3.5 Turbo 0301 older version of the model. So let's run this. So the code snippet imports components from the LangChain library, which is a powerful tool for working with the language models in more structured and interactive ways. It imports a chat OpenAI from the langchain.chat models, which is a class that allows you to easily interact with the OpenAI's chat models like GPT-3 or GPT-4 for generating the conversational responses. Then it brings in conversation chain from the LangChain, and lastly the conversation and buffer memory from the langchain.memory is imported to handle the memory of the conversation. Basically it stores and retrieves the previous exchanges so the conversation feels more coherent and natural, with the model remembering the past inputs. So all of these components work together to build an interactive chat experience where the model can maintain the context and the flow throughout the conversation. So let's run this. So in this code, you are setting up a conversational AI experience using the LangChain library. So first, the LLM variable is initialized with the chat open AI class, where the temperature is set to 0.0 argument, ensures that the model's responses are deterministic, meaning it will give the same output for the same input every time, which can be used for the control interactions. The model is equal to LLM model parameter uses the model name that was defined earlier. So here, then the conversation variable creates a conversation chain which ties everything together. So it connects the LLM with the memory and sets verbose is equal to true to ensure that the detailed logs of the conversation are printed out, making it easier to debug or analyze the interaction. So let's run this. So here we are sending the input, "Hi, my name is Andrew," to the model. The conversation object, which was set up earlier, processes the input and generates a response based on the context it has stored in the memory. Now you can see, "Hello, it's nice to meet you. How can I assist you today?" Behaves like a chat. And here the line sends the input, "What is 1 plus 1 to the model again?" So we will see, and you can see 1 plus 1 equals 2. Is there anything else you would like to know? So it definitely behaves like a chat. So here, when you call the chat conversation.predict input, "What is my name?" you're asking the model to recall and respond with your name. Since the conversation memory is active, the model will just look back at the previous conversations to see if it has already learned your name. So if it has, it will reply with, "Your name is Andrew." And you can basically see it has been imported with memory. So here the line print memory.buffer is used to display the contents of the conversation memory. Since the memory is an instance of the conversation buffer memory, it stores all the exchanges that have taken place during the conversation. So by printing memory buffer, you can see the entire conversation history over there. Basically, you can see the whole history. Here, this is used to load the current memory variables into the conversation. So in this case, the third bracket is an empty dictionary, which means you are effectively asking to retrieve all the memory stored so far, but without any specific filtering or conditions. This can help in accessing or managing the entire conversation history stored in the memory, giving you a snapshot of what the model remembers from the interactions so far. So let's see. So it basically remembers everything. So this line basically initializes a new instance of the conversation buffer memory, which is a special type of memory used to store the conversation history. So let's run this. So here the line memory save context input hi output WhatsApp is saving a new interaction to the memory buffer. So the input hi represents what the user said and output WhatsApp represents the model's response. So by calling the save context, you are telling the conversation buffer memory to store this as a pair of input output so the model can refer back to them later in the conversation. So let's see this. Now finally, we are printing the memory buffer is used to display all the stored conversation history in the memory object. So since memory is an instance of the conversation buffer memory, it keeps track of each user input and output response. So by printing the memory.buffer, you are essentially showing the entire conversation log so far. This is helpful for debugging or understanding how the model is processing the conversation over time. So the line memory.load memory variables is a way to retrieve and inspect the stored memory from the conversation buffer memory object. So here the empty third slash is an empty dictionary, meaning you are just asking to load all the memory variables without any specific filters or conditions. Here we are importing conversation buffer window memory from the langchain.memory, and let's run this. So here this code basically creates an instance of the conversation buffer window memory with a window size of 1, meaning the memory will only store the most recent interaction, both input and output. The parameter k is equal to 1 defines that the window will hold just one exchange at a time, discarding the older conversation history. So this setup is helpful when you want the model to focus only on the immediate context, keeping things lightweight and efficient, especially in the longer conversations. So here basically we are saving the content, that is a key value pair, and input hi, output is WhatsApp, input is not much, just hanging, output is cool. So let's run this. So here basically we are used to load the stored memory from the conversation buffer memory object. The empty dictionary means you are not applying any specific filters, so it's simply retrieving all the memory variables stored in the buffer. So let's run this. So this code is setting up a conversation with an AI model using the LangChain library. So first, the LLM variable is initialized with the chat OpenAI, setting the temperature to 0, which means again the model's responses will be more deterministic. Then the model is chosen based on the LLM model variable, which could dynamically switch between different versions. Next, memory is equal to conversation buffer window, k is equal to 1. Creates a memory that only remembers the most recent interaction. Finally, the conversation variable is set up with the conversation chain, which links the model. Then we have verbose equal to false argument, means that the detailed logs of the conversation won't be shown, keeping the output clean. So let's run this. So here, basically, we have a conversation.predict, which basically sends the input, hi, my name is Andrew, to the model for processing. So this model uses the most recent exchange to generate a natural relevant reply. This is how the conversation begins, with the model acknowledging or responding appropriately to the user's introduction. Then again we are sending the question, what is 1 plus 1 to the model. The conversation object uses that input to generate an appropriate response. Since this is a simple math question, the model will likely respond with the correct answer as 2. This shows how the conversation dynamically builds on each exchange, maintaining the context and the respondingly accordingly. Since here the memory is set up to store the past interactions, the model can look back at the previous exchange where the user introduced themselves as Andrew. So your name is Andrew. This ensures the conversation feels natural and coherent with the model remembering and re-answering the prior inputs. So here we have a conversation token buffer memory, and we will run this. So here the code starts by importing the conversation token buffer memory from the LangChain, which is a type of memory that basically stores the conversation history in terms of tokens. So the OpenAI is imported from the langchain.llms. Next, the LLM variable is initialized with the chat OpenAI, setting the temperature to 0.0 for deterministic responses and selecting the model based on the LLM model. This ensures that the model will generate the consistent outputs based on the given version. So let's run this. So here we are basically storing the conversation history based on the tokens and limits the total tokens to 50 to manage the memory efficiently. So 3 interactions are saved using the save context, each with a user input and the model's corresponding output. So these exchanges are stored in the memory with the most recent conversation, potentially pushing out the older ones if the total token count exceeds the max token limit of 50. So let's run this. So here the line memory.load memory variables is used to load the current stored memory from the conversation token buffer memory. The empty dictionary again indicates that no filters or conditions are applied. Essentially, this command allows you to access the stored conversation context, such as the inputs and the outputs the model has processed, giving you a snapshot of the conversation's history up to that point. It's useful for reviewing or manipulating the memory content during the interaction. So let's run this. So after we have imported memory to the model, let's understand chains in the LangChain in the next chapter. Now, let us understand what is a chain. In the context of LangChain, a chain is a sequence of steps or components that work together to accomplish a specific task. These steps can be individual operations such as generating text, using a language model, or storing data in memory. A chain can link different parts of the process like the model, the memory, and the tools, ensuring everything flows smoothly from one step to the another. Think of it like a relay race where each runner passes the baton to the next runner, completing the task as a team. Then let us understand why chains matter. So chains organize tasks. They help structure and streamline the way different tasks are carried out in a process. Then, without chains, managing operations become complex. So without a chain, you would need to handle each operation separately, which can get complicated, especially when combining different models, tools, or information sources. Then we have chains create a clear workflow. They set up a repeatable process where each step builds on the previous one, making everything flow smoothly. Then we have chains help scale complex tasks. By using chains, it becomes easier to manage and scale complex systems, ensuring all the parts work together harmoniously. Then we have chains simplify and automate tasks. They reduce the need for manual work, making it easier to handle repetitive tasks automatically and saving time and effort. The first is input is provided. You start by giving an input to the chain. Then we have processing the input. The input passes to the first step in the chain, which could be a language model or a tool that generates a response based on that input. Then we have modify or store the response. The response from the first step is passed to the next step, which could involve storing that response in memory, modifying it, or performing another action like data processing. Then we have output is produced. The final step processes everything and output the result, whether it's an answer, action, or another response. Then we have behind the scenes operation. The chain handles all of these steps automatically, so you don't have to worry about each individual operation, letting you focus on the higher level task. So think of it like an assembly line where all the raw materials, that is the inputs, are processed at different stages to create the final product, that is the output. Now let's see everything in action. So this little piece of code is using Python's warnings module, which is kind of like a built-in system that alerts you if something might go wrong in your code. So this can be helpful if you are working with the code that gives harmless warnings and you just want a cleaner output, but just can be careful not to miss anything important. So let's run this. Here the code is using the Python's .env module to load environment variables from a .env file. So first it imports the necessary functions like the load.env to load the variables and the find.env to locate the .env file. Then the dash is a common way of saying I don't need to use the result of this, just do it. So basically it's setting up your program to securely read any private settings it needs from a little file without hard coding them into your script. So let's run this. So this code I have already explained before. The code checks the current date has passed a specific target date, that is June 12, 24, and then it decides which version of the language model to use. So let's run this. So let's now install pandas. So here basically we are importing the pandas as PD and then we are reading that CSV file, and so I have run this. So this is basically to see the first few rows of the particular file, and you can basically see 0, 1, 2, 3, 4, 5 rows. So here we are again importing some things from the LangChain, chat OpenAI, chat prompt template, and then LLM chain. So this line of code is creating a new instance of the chat OpenAI model from the LangChain library. The temperature is again set to 0.9. Setting controls how creative or random the model's responses are. A higher temperature of like 0.9 makes the responses more diverse and less predictable, while a lower temperature makes them more focused and deterministic. So let's run this. So here we are basically creating a prompt template using the chat prompt template dot from template. So the template here asks what is the best name to describe a company that makes particular product, where product is a placeholder that will be filled in with an actual product name when used. So when you use this prompt, you can plug in any product name like bicycles or gadgets, and the model will respond with the suggested company name based on that product. So it's a way to make the prompt flexible and reusable for different scenarios. So here basically we are creating a new LLM chain object, which is a way to link the large language model with a specific prompt. So let's run this. So here in this code, the variable product is set to the value of queen size sheet set, which is a product for which the model will generate a response. So the LangChain.run product is using the LLM object to run the model with the given prompt, filling in with the placeholder of with queen size sheet set. So when this runs, the model will use the prompt, what is the best name to describe a company that makes a queen size sheet set, to generate an answer. So here basically we are importing the simple sequential chain from the langchain.chains module. Then simple sequential chain is a tool in the LangChain that allows you to create a sequence of tasks where each task output is used as the input for the next one. So we'll run this. So this code sets up a sequence to generate a company name based on the product description using a language model. So LLM is equal to chat OpenAI. This basically creates an instance of the chat OpenAI model with a creativity level of 0.9 and specifies the model to use. Then we have first prompt is equal to chat prompt template and everything. So this creates a prompt template that asks the module for the best company name for a product. So the part is a placeholder that will be replaced with an actual product name when you see it. Then we have chain 1 is equal to LLM chain. This creates LLM chain linking the language model with the prompt. The chain is set up to take the model input as input, apply the template and generate a response suggesting a company name. So we'll run this. So here the part of code sets up a second chain of the actions. First it creates a new prompt template called the second prompt, which asks the model to write a 20-word description for a company. Then it creates a second chain, that is chain 2, which links the same language model to this new prompt. So this idea is that after the first chain generates a company name, this second chain will take the name and generate a short 20-word description of the company. So let's run this. So this line of code creates a simple sequential chain called the overall simple chain, which combines the two chains. So the simple sequential chain is used to link these two tasks together in a step-by-step manner. So the verbose is equal to true part ensures that the process will print out the detailed information about each step as it runs, so you can see what's happening during the execution as well. So let's run this. So here in this code, by calling the overall simple chain.run product, you are actually triggering the entire process in one go, and the model will output both the company name and the description based on the input product. You can see. So let's begin with the sequential chain, and for that we are importing sequential chain from the LangChain. Now here we can basically see that we have prompt template 1, that is translate the following review to English. And then we have chain 1, that is output key is equal to English review. So let's run this. So just like the first one, we will pass various second prompts and chain 2. And here in the second prompt we have can you summarize the following review in one sentence. And for chain 2 we have output key is equal to summary. So let's run this. So here we have prompt template 3 translate to English. Third prompt, that is what language is the following review. And then we have chain 3, that is output key is equal to language. Then we have a fourth template and chain 4 as well, and we'll run this. So this code basically creates an overall chain that combines all 4 chains into one continuous process using the sequential chain. So the overall chain is designed to take a review as input and produce the 3 outputs. And the first translating the review, then summarizing it, then identifying the language, and then finally generating the follow-up message. So the input variables review specifies that the input to the overall chain is the review, while the output variables indicates that the outputs will be these 3 values. The verbose is equal to true part ensures that the details of each step in the process will be printed for clarity. So let's run this. I have already run it. So in this code, the review is equal to df.review5 selecting the 6th review since indexing starts at 0. From the column review in the df data frame and storing it in the variable review. So let's run this. So in this code, 4 different templates are defined to guide the language model's responses depending on the subject of the question. So here each template sets the context and the tone for how the model should respond depending on the area of expertise. The physics template, this template sets the model as a smart physics professor who answers questions about the physics in a clear and concise way. Math template, here's a model is set up as a good mathematician who answers the math question by breaking down the complex problems into simpler components. Then we have history template. So this template positions the model as an expert historian with the deep knowledge of people, events and context from various historical periods. Then we have computer science template. So this sets the model as a successful computer scientist with strong problem solving skills, knowledge of algorithms and the ability to explain the coding solutions clearly. So each template has a placeholder, that is input, where the actual question will be inserted when the template is used. So let's run this. So here we have basically the prompt infos list is created to store the information about the 4 different subject areas like the physics, maths, history and computer science. So each item in the list is a dictionary containing the 3 keys: name, description and the prompt template. So the prompt infos act as a collection of the subject specific templates and descriptions that can be used to choose how the model should respond based on the area of expertise. You can use this information to select the right template for the model when asking for a question about a specific topic. So I'll give this as input. So here we are basically importing the multi-prompt chain, the LLM router chain, router output parser and the prompt template from the langchain.js and prompts. So let's run this. So basically we have created an instance of the chat OpenAI model, setting its temperature to 0, which means the model responses will be very focused and deterministic. And the model is equal to LLM model. Part specifies which version of the model to use with the LLM model, being a variable that holds the model name, for example, GPT 3.5 Turbo. So basically this is a configuring state. So this code is basically setting up a dynamic system where multiple chains are created based on the subject areas and stored in the dictionary. So finally, when the list destination is joined into a single string, there is a destination str with each entry separated by a new line. The destination str will contain a neatly formatted list of all the available subject areas with their descriptions, which could be useful for displaying options or instructions for the user. So in short, this code dynamically creates a set of chains based on the subject areas and prepares a list of these subjects with descriptions. So for here, we have a default prompt is created using the chat prompt template dot from template. This is a simple template that takes whatever input is given and passes it along to the model without any specific formatting or modification. So the input placeholder just ensures that the text provides as its input is directly used, as in making this template a catch-all for any input. So here we have created the multi-prompt router template. Is designed to basically select the best suited prompt for a given input. It provides a task where the model is given several prompts with a description and has to choose one that fits the input. The model can also modify the input if needed for a better response. The output is a markdown code snippet with a JSON object containing the 2 value pairs: destination and the next inputs. The candidate prompt section lists the available prompts and the input placeholder holds the raw text input. So the template helps route the input to the most relevant prompt based on its content, allowing dynamic handling of different tasks. So here, this code sets up a dynamic routing system that selects the most appropriate prompt for a given input using the multi-prompt router template. So first, if it creates the router template by formatting the multi-prompt router template with the destination str, which contains a list of available prompts and their descriptions. So in a sense, this code basically sets up an intelligent routing system that dynamically evaluates the input and routes it to the appropriate prompt, making the system flexible and adaptable to various types of queries. So here basically this line of code sets up multi-prompt chain which combines the routing system and the multiple destination chains in one cohesive workflow. In summary, this code basically creates a flexible and comprehensive multi-prompt chain that dynamically routes inputs to the best suited response based on the context, with a fallback option for general queries. So this line of code basically executes the chain.run method with the input what is black body radiation. So when the chain is run, the first step is that the router chain evaluates the input question to determine the most appropriate prompt. Given that the question is related to a physics concept, the router chain will likely route to the input to the physics prompt. Next, the system generates the corresponding physics chain from the destination chains dictionary to process the question. Lastly, because the verbose is equal to true setting is enabled, the system will print the detailed information about the routing process and the response is generated, making it clear how the input was processed and which prompt was used to generate the answer. So here we are basically running when the code chain.run, why does every cell in our body contain DNA? So is executed, the router chain will evaluate the input question and the default chain will then handle the question and the language model will generate a general response that might explain the importance of DNA in the cells. With verbose is equal to true, the process will log the routing decisions and show how the question was processed, including any details about which prompt was chosen and what response was generated. So, after we have actually understood all this, let's now see on the next chapter what is about building smart QA systems with the LangChain. So now we have what is QA. QA or question answering is a task in natural language processing where the goal is to develop models or systems that can understand and respond to the questions posed in the natural language processing. So essentially it's about teaching machines to answer questions based on either a given passage of text, knowledge base, or even their understanding of the world. Then let us understand why is QA so powerful. QA is powerful because it enables machine to interact with the humans in a way that mimics how we process and respond to information. So QA systems have the ability to provide instant answers. So QA systems can quickly deliver accurate answers to a wide variety of questions, which can be incredibly helpful in fields like customer service, education, or research. Then we have enhanced user experience. So with accurate human-like responses, QA systems improve the user experience, allowing people to get the information they need more efficiently. Then it has handled complex queries. Advanced QA systems, particularly when integrated with LLMs, can process complex multiple-step questions that require reasoning or understanding beyond simple factual recall. Now let us understand how does QA work. So the process begins when the user provides a question ranging from simplex to complex. The next is in LangChain, the question is routed through the prompt templates or chains to refine it before processing. The language model processes the input and generates an answer based on its knowledge. Then we have once processed, the model generates an output that is displayed to the user. Then if we needed, a feedback loop may ask for clarification for ambiguous or the complex questions. Now let's see all those in action. So here basically we are installing the upgrade LangChain and let's run this. So here basically we are configuring our Python environment to securely manage the sensitive information like the API keys or database credentials. So here by importing the load.env and the find.env functions from the .env package, you enable your application to locate and load the environment variables from a .env file with your environment. So the find.env function searches for the env file starting from the current directory and then the path to the first.env file it finds. The load.env function that loads the environment variables from this file into your environment. So finally run this. In this code, the goal is to select the appropriate version of the GPT 3.5 Turbo model based on the current date, considering the model's deprecation timeline. So the code first retrieves the today's date and sets a target date of June 12, 2024. It is significant because the certain versions of the GPT 3.5 Turbo, such as the GPT 3.5 Turbo 0613, were deprecated around that time. So I have explained this before. So here we are importing some retrieval QA, chat OpenAI, CSLV, loader, doc array, in-memory search, display, markdown, and OpenAI from the LangChain chains, chat models, document loaders, vector stores, delays, basically the environment variables to set up a particular project. So in this code, you are utilizing the LangChain CSLVL loader to load the data from a CSV file named the outdoor clothing catalog. By creating an instance of the CSVL loader with the specified file path, you are preparing to read the CSV file and convert each row into a document object. So let's run this. So here basically we are importing the vector store index create on langchain.indexes, and let's run this. So here we are installing the doc array and we will install this. So here basically we are creating an index to efficiently search and retrieve the documents using the LangChain's vector store index in combination with the doc array memory search. So by specifying the vector CLS equal to doc array in memory search, you are opting for an in-memory vector store that allows for the exact search capabilities. So we'll run this. So here when selecting shirts with the sun protection, it's important to consider the material, weave, density and color as these factors influence the UV shielding effectiveness. So brands like Solimbrum specialize in clothing with a high UPF ratings, providing garments that block a significant amount of UV rays. So here we are basically setting up a question answering system using the Llama index with the OpenAI's GPT 3.5 Turbo Instruct model by specifying the LLM represent model equal to OpenAI temperature is equal to 0 and the model is GPT 3.5 Turbo. So we are configuring the system to use the specific model for generating responses. So here we'll run this. So here we are basically utilizing the IPython's display and markdown functions to render the response object as formatted markdown within a Jupyter notebook. So by passing this response to the markdown, you are instructing IPython to interpret and display the content with appropriate markdown formatting. And now basically you can see the output. So in this code, you are utilizing the LangChain CSVL loader to load data from a CSV file into a list of document objects. So by specifying the file path, LangChain reads the CSV file and converts each row into a document where each column in the row becomes a key value pair in the document's content. So we'll run this. So here the loader.load method reads the CSV file specified by the file path and converts each row into a document object. So each document contains the data from one row with the columns represented as the key value pairs in the document's content. So let's view the first document over here. And you can see you have got the output. So here basically we are creating an instance of the OpenAI embeddings class from the LangChain, which allows you to generate the vector representations for the text data using the OpenAI's models. So embeddings are the numerical vectors that capture the semantic meaning of the text, enabling the applications like the semantic search, clustering and the recommendation systems. So by initializing the embeddings, you are setting up the system to use OpenAI's default embedding model. So here basically we are using the embed query method from the LangChain's OpenAI embeddings class to convert the input text, "Hi, my name is Harrison," into a numerical vector representation. So this transformation basically captures the semantic meaning of the text, enabling applications like the semantic search and the clustering to process and analyze the content effectively. So here basically we are determining the dimensionality of the vector generated by the text embedding adder. So this model produces embeddings with the 1536 dimensions, meaning the length of the embed vector will be 1536. Here, by executing the print embed :5, you are displaying the first 5 elements of the embedding vector for the phrase "Hi, my name is Harrison." So in Python, the slice notation of :5 retrieves the elements from the start up to but not including the index 5. So this operation allows you to inspect the initial components of the embedding, which are numerical representations capturing the semantic meaning of the text. So here basically in this line db is equal to doc array memory search, you are creating an in-memory vector stored using the LangChain's doc array in-memory search. So this store allows for the efficient similarity searches within your dataset. So let's run this. Then we are passing one query, please suggest a shirt with the sun blocking. And now basically you can just pass this query, call this similarity search and check. Now let's see the length of the docs. It's 4. And now here we can actually view the first document. And now basically you can retrieve the DB and we are again calling the chat OpenAI using the temperature is equal to 0 and model is equal to LLM. For here, this is basically a for loop for I in range of length documents, and we are then we are passing one response calling this LLM function. Now let's see this display, and now basically you can see this verbose equal to true. For this LLM equal to LLM, chain type equal to staff. And now we are basically passing one query over here. Now basically you can see the response over here, and now you can basically see the markdown response. And now you will gonna see that we have passing this query in this response, index.query, query and LLM. So we'll run this. So here we are basically creating embeddings and vector store and then calling the loader class, and finally we'll run this. So after we have a basic understanding of how question answering actually works, we'll see how to actually evaluate the system we have created. So here basically we are importing the necessary modules to load the environment variables from a .env file using the .env library. So it first imports the OS module, which provides functionality to interact with the operating system, including the environment variables. Then it imports the load.env and find.env from the .env module. Then let's run this. So I have basically explained this almost 2-3 times, so I'm not explaining once again. So we'll run this. So here once again we are importing the retrieval QA from LangChain, then we are importing chat OpenAI, then we are importing CLVL loader, then we are importing vector store index and doc array in memory search. So we'll run this. So this code loads data from a CSV file named outdoor clothing catalog 100.cav. So it first defines the path in the file variable, then uses the CLVL loader class from the LangChain document loaders to load the CSV file. So we will run this. So here the code creates a vector store index using the vector store index creator class. It specifies the doc array in memory search as the class for the vector store, which stores the document embeddings in memory for efficient search. The from loaders method loads the data from the previously defined loader, processes it and creates an in-memory index that can be used for the fast document retrieval based on the vector embeddings. So we'll run this. So this code basically sets up a question answering system using the retrieval QA class that initializes a language model with the chat OpenAI, setting the temperature to 0.0 for deterministic responses. The QA system is then created using the from chain type method, where the model processes data in the stuff chain, and the vector store is used as the retriever to fetch the relevant documents for question answering. So additionally, verbose logged is enabled for tracking the process, and a custom document separator is then specified. So let's run this. Coming up with the test data points, that is in this code the data 10 is accessing the 11th element. So let's see. So in this code data 11 is accessing the 12th element, since indexing starts at 0 from the data list or array. If data contains the rows loaded from the outdoor clothing catalog 1000.csv file, this will return the 12th row of data. So the structure of the data will depend on how the CSV file was loaded. So if data is a list of dictionaries or a similar structure, data 11 will give you the dictionary or row that corresponds to the 12th entry in the CSV. So here the code defines a list called the examples, which contains the two dictionaries representing the question answer pairs. Each dictionary includes a query key with the question being asked, such as do the cozy comfort pullover set have side pockets, and what collection is the ultra lofty 850 stretch down hooded jacket from. So the structure can be used for training or testing a question answering system where the questions are matched with their correct answers. So let's run this. So here basically we are importing the QA generate class from the langchain.evaluation.qa, and here the code initializes a QA generated chain object using the from LLM method. Here's a breakdown of what actually basically happening. So example gen chain is equal to QA generated chain dot from LLM. This creates a QA generated chain object called the example chain which is set to generate the question answer pairs. Then we have chat OpenAI model equal to LLM model. This initializes a chat OpenAI model with a specified LLM model. So in summary, this code actually sets up a chain that can generate the question answering pairs used as a language model through the chat OpenAI class, which can be used for the various QA tasks. So here this code generates a new question answer pairs by applying the QA generator chain to the first 5 documents in the data list. So it uses a list comprehension to create a list of the dictionaries where each dictionary contains a document wrapped with the key doc. So then let's move on. So let's have a look on the first example. Then let's see the first data we had. And this is the document page. This is basically incrementing the examples with the new examples, and we'll run this. And then we have this code executes the first query. And from the examples list by accessing the query field of the first example, which is in this case is do the cozy comfort pullover set have side pockets. So here when you set the langchain.debug is equal to true, you are telling the LangChain library to show the detailed information about what it's doing behind the scenes. It will print out the debugging messages and like the errors messages, and it takes the step it's taking while running your code. Now let's see the first query, and you can basically see it is debugging. So basically we are turning off the debug mode over here. So let's now move on and see how to build agents with the LangChain. So in this lesson of building agents with LangChain, we will basically see how to actually build agents. We are first importing the OS, then from .env we are importing load.env and find.env, basically for reading the local env file. And then we are importing the warnings for warnings.filter warnings ignore. Basically we are creating the project environment. And then this code is designed to automatically switch to a newer version of the LLM model after a specific date. It first imports the datetime module to handle the date operation, then retrieves the current date. So we'll run this. So here basically we're installing the Wikipedia, and we'll run this. So here we are finally importing the create Python agent, and then we're importing load tools, initialize agent, agent type, Python RPL tool, then we're importing Python RPL and chat OpenAI. So we'll run this. Basically path of the configuration, we are calling the chat OpenAI. We are setting the temperature to 0 and passing the model as LLM model. So we'll run this. And then basically we are using the load models LLM Math Wikipedia, loading a set of tools, and then we are running this. So basically we are this line of code basically loads a set of tools, especially LLM Math and the Wikipedia, and associate them with the previously defined language model. So here again we will move on. So here this line of code initializes a chat based agent using the initialize chat agent function, setting it up with the specified tools like LLM Math and Wikipedia. The agent is configured as agent type.chat0, and then we'll run this. So this line of code basically processes the query, what is 25% of 300. When the agent is called with this input, it will leverage the tools and the language model defined earlier to compute the result, especially the LLM Math. tool will handle the mathematical calculation and the agent will respond with the correct answer. So in this code, the variable question contains a query asking about the book written by Tom Mitchell, an American computer scientist and a professor at the Carnegie Mellon University. So in this case, the agent will likely return the name of the book written by the Tom M, which is machine learning, a well-known textbook in the field of machine learning. So this result is stored in the result variable. So we'll run this. You can basically see the observation, the thought, then again observation, page, line. I have found that Tom M wrote the book Machine Learning. I now know the final answer. This line basically creates a Python agent using the create Python agent function. This agent is configured with a specified language model to handle the task and generate responses. So it also uses the Python RPL tool, which allows the agent to execute the Python code in a real eval print loop. So we'll run this. So basically this is a customer list which contains the sublist. So each sublist represents a customer with two elements, the first name and the last name of the customer. For example, Harrison and Chase, and like this it follows. So we'll run this. This line of code instructs the agent to sort the customer list first by last name and then by first name. So the run method is called with the formatted string where the customer list is passed as part of the query. So I'll run this. So this code basically enables the debugging in LangChain by setting the langchain.debug equal to true, which provides the detailed logs and information about the operations performed by the LangChain agent. Then it runs the agent to sort the customer list by the last name first and then by first name as requested. So we'll run this. Then we are installing this date time for defining our own tool. So to build our own tool, we are importing tool and date from datetime and tool from the langchain.agents. This code defines a tool function called the time using the @tool decorator from the LangChain. The function takes a single parameter text which is expected to be an empty string and I return the today's date as a string. The doc string clarifies that the function is specially designed to provide the current date and should only be used for this purpose. So let's run this. So this basically initializes an agent using the initialize agent function, which configures the agent with a combination of predefined tools and the newly added time tool for retrieving the today's date. The agent uses a specified language model to handle tasks and generate responses. So we'll run this. So this code basically attempts to query the agent with the question, what's the date today, by calling the agent with that input, expecting it to respond with the current date using the time tool. If the agent encounters any error during execution, such as issues with external access or tool failures, the program will handle it gracefully by moving to the expect block. In case of an error, the message exception on the external access is printed, indicating that something went wrong while trying to retrieve the information. So this setup ensures that the process doesn't crash and provides a clear error message if an issue occurs. So guys, congratulations on completing the LangChain for LLM App Development course. You have taken a significant leap towards mastering the AI-driven language models and their integration. Now it's time to apply your skills, experiment with LangChain, refine your LLM's reasoning capabilities, and explore innovative ways to enhance the automation and contextual understanding. Keep pushing the limits of AI and unlock the full potential of LangChain in your projects. Happy coding and thank you for being a part of this exciting journey.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.